Chapter 1.5.11 Service Cluster IP Allocation. In Kubernetes, services are used to expose applications running on a set of pods. Services have a cluster-scoped virtual IP address and can be of type ClusterIP. Clients can connect to the virtual IP address, and Kubernetes will load balance traffic across the different backing pods for that service. This abstraction simplifies networking for applications in Kubernetes. How service cluster IPs are allocated. Kubernetes assigns virtual IP addresses for services in two ways, dynamically or statically. When using dynamic assignment, the cluster's control plane automatically selects a free IP address within the configured range for type cluster IP services. With static assignment, you choose a specific IP address within the range. It is important to ensure that every service cluster IP is unique across the whole cluster. Attempting to create a service with a cluster IP that has already been allocated will result in an error. Why do you need to reserve service cluster IPs? In Kubernetes, it is common to assign well-known IP addresses to certain services, such as the DNS service for the cluster. However, there is a risk of IP address conflicts if the IP address is not reserved. For example, if the service IP range is set to 10.96.0.0/16 and you want the DNS service IP to be 10.96.0.10, there is a chance that this IP address could be allocated to another service, resulting in a conflict error when creating the DNS service. How can you avoid service cluster IP conflicts? In Kubernetes, the allocation strategy for assigning cluster IPs to services minimizes the risk of collision. The cluster IP range is divided based on a formula that ensures it is never less than 16 or more than 256, with a gradual step between them. Dynamic IP assignment starts with the upper band and switches to the lower range once the upper band is exhausted. This allows users to use static allocations on the lower band with a reduced risk of collision. By following this allocation strategy, Kubernetes effectively manages the distribution of cluster IPs to services while minimizing the possibility of conflicts. The text discusses three different examples of IP address ranges for services, using CIDR notation. In example 1, the range is 10.96.24 with a range size of 254. Example 2 uses the range 10.96.20 with a range size of 4094. Example 3 uses the range 10.96.00/16 with a range size of 655534. Each example includes calculations for band offset, static band start and end, and range end. Additionally, they show the percentage of dynamic and static IP addresses in each range. Overall, the examples demonstrate how different CIDR notations can affect the size and distribution of IP address ranges.